Hello, this is Rain from Exam Hub. Today I'll be solving Chemistry Paper 2 AS Level Structured Questions 9701 Variant 2 May-June 2020. Question number 1. Gallium is an element in group 13. A sample of gallium is analyzed using a mass spectrometer. The mass spectrum produced is shown. Part A. Explain what is meant by the term relative atomic mass. So relative atomic mass is mass of 1 mole of atoms as compared to 1/12 of 1 mole of carbon-12. Part B. Calculate the relative atomic mass of gallium in the sample. Give your answer to 4 significant figures. Show your working. So gallium has got 2 isotopes. Gallium with isotopic mass of 69 and gallium with isotopic mass of 71. So we must consider both the isotopic masses to get a common mass for an atom of gallium. So we'll write relative atomic mass is equal to the first isotopic mass of gallium, which is 69, multiplied by the percentage abundance of that isotopic mass of gallium, which is 60.11, plus the second isotopic mass of gallium atom, which is 71. This also gets multiplied by relative abundance, which is 39.89. Now this whole gets divided by 100, and now we have the value for relative atomic mass of a gallium atom as 69.80. Part C. Complete the table which describes a gaseous atom of gallium. So gallium has a nucleon number of 71. Nucleon number is the mass number of gallium atom. Total number of electrons in lowest energy level is 2. Since lowest energy orbital of gallium atom is S of principal quantum shell 1, which has got 2 electrons, and type of orbital which contains the electron in the highest energy level. For this first I'll write the electronic configuration of gallium atom, which is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and the last one is 4p1. You see that the highest energy level is 4p with only 1 electron. 1 over here indicates that 4p has got 1 electron, so this orbital is p with quantum shell 4. So type of orbital is p. Part D. When gallium is heated in excess chlorine, gallium trichloride GaCl3 is made. Draw the shape of the gallium trichloride molecule and suggest the chloride to gallium to chloride bond angle, shape of molecule. Okay. Since gallium has got only 3 valent electrons, and all those 3 electrons are unpaired and they experience equal amount of repulsion amongst each other, hence the bond angle of Cl to Ga to Cl is 120. Part E. Gallium oxide and aluminum oxide react in the same way with HCl and with NaOH. Part 1. Suggest the equation for the reaction between gallium oxide and HCl. So aluminum oxide is an amphoteric acid, so is gallium oxide. Gallium oxide reacting with HCl. This would give me water plus salt, which is gallium chloride. Okay, now we need to balance this equation. 2 moles of gallium chloride, 3 moles of water, and 6 moles of HCl. Part 2. Suggest an equation for the reaction between gallium oxide and NaOH. So gallium oxide reacting with NaOH. This gives sodium gallate plus water. Just like aluminum oxide plus NaOH would give sodium aluminate and water. This gives NaGaO2 plus water. Question number 2. Nitric acid can be made in a three-stage process. Stage 1, ammonia is oxidized by oxygen from the air to form nitrogen monoxide and water. This reaction is carried out at 10 to 13 atmospheres pressure and 900 degrees Celsius in the presence of a platinum catalyst. Stage 2, nitrogen monoxide reacts with more oxygen to form nitrogen dioxide. Stage 3, nitrogen dioxide reacts with water to make nitric acid and nitrogen monoxide. Part A. Write an equation to show the reaction occurring in stage 1. So stage 1 says that ammonia gets oxidized by oxygen and forms nitrogen monoxide and water. So ammonia plus oxygen, this gives nitrogen monoxide plus water, and there will be 6 moles of water, 4 moles of nitrogen monoxide, 5 moles of oxygen gas, and 4 moles of ammonia gas. Part B, draw a dot and cross diagram to show the arrangement of outer electrons in a molecule of ammonia. Nitrogen has got 5 outermost electrons. It will be sharing 3 of its electrons. Each of it will be with hydrogen atom. So lone pair of electron of nitrogen will have greater repulsion than bonded electrons. Thus the bond angle ain't like gallium chloride like in the previous question. Part C1, in the boxes give the oxidation numbers of nitrogen in the nitrogen containing species for the reaction in stage 3. So nitrogen over here has an oxidation state of +4, +5, and +2. Part 2, explain why the reaction in stage 3 is described as disproportionation reaction. Include reference to transfer of electrons in your answer. So a disproportionation reaction has one species getting both oxidized and reduced in the same chemical reaction. In this question, I see that it's nitrogen which is getting oxidized from +4 to +5 and reduces from +4 to +2. So it's nitrogen that gets oxidized. By losing electrons from NO2 to HNO3. And we need to show that in terms of number 2, so +4 to +5, this is oxidation number. Increase in oxidation number is oxidation, and gets reduced to by gaining electrons from NO2 to nitrogen monoxide. And the oxidation state changes is +4 to +2. Decrease in oxidation number is reduction. Part D, the release of nitrogen monoxide into the atmosphere causes atmospheric pollution. State and explain the effect of nitrogen monoxide gas in contact with moisture. So nitrogen monoxide, when it gets in contact with moisture, it may oxidize to form nitrogen dioxide, which if reacts with water can form nitric acid, and that causes acid rain. So we can mention that nitrogen monoxide oxidizes to nitrogen dioxide and react with water to form nitric acid, which causes acid rain. Part E, the nitric acid made in stage 3 can then be reacted with ammonia to form ammonium nitrate. Stage 3 is nitrogen dioxide reacting with water to form nitric nitric acid and nitrogen monoxide, that same amount of nitric acid reacts with ammonia to form ammonium nitrate. Calculate the volume of nitrogen dioxide measured at room temperature and pressure required to make 40 tons of ammonium nitrate. And 1 ton is equals to 1000 kgs. Show your working. Okay, so 1 ton is equals to 1000 kgs, so that makes 40 tons equal to 40,000 kgs of ammonium nitrate. We can't compare masses, so it's best to convert them to moles and then use mole ratio. Moles of ammonium nitrate is equal to 500. Since nitric acid is present in both the reactions here and here, we can use its number of moles in mole ratio. 500 moles of ammonium nitrate need 500 moles of nitric acid. And question says that same amount of nitric acid which was produced in stage 3 was used to form ammonium nitrate. This means 500 moles of nitric acid were formed in stage 3. So, moles of HNO3 in stage 3 is equal to 500 mole. So, mole ratio of nitrogen dioxide to nitric acid is 3:2. From here, 3:2. Hence, number of moles of nitrogen dioxide used are 750. Now we can multiply 750 with 24 decimeter cube because that's the molar volume of a gas. That gives us 18,000 decimeter cube of nitrogen dioxide. Part F, state 1 use of ammonium nitrate. So this compound can be used as a fertilizer. Question number 3, sucrose reacts with water to form glucose and fructose in reaction A. Part A, suggest a name for this type of reaction. So addition of water to the structure is known as hydrolysis. Part B, explain in detail why glucose and fructose are a pair of structural isomers. Your answer should refer specifically to these two molecules. So glucose and fructose both have same molecular formula but different structural formula. We can write that. So both have same molecular formula but different structural formula. That is C6H12O6. Also, same type of atoms are present in both glucose and fructose, but different functional groups are present at different positions in both the structures. Like glucose has got an aldehyde group right hand of the structure, while fructose has got a ketone group which is kind of in the middle because it is not at the end of the chain. Either sides it's the alcohol group present, so we can mention that as well. Same type of atoms but at different positions for both structures. It says that your answer need to specify both these structures specifically, so we can write like glucose has an aldehyde group right at the end of the chain, whereas fructose has a ketone group. By the way, both are carbonyl compounds, but they are different groups. That ketone group is present in the middle of chain. Part C, reaction A occurs faster in the presence of an enzyme. This is reaction B. Part 1, the activation energy for reaction B is positive 29 kilojoules per mole. Predict a value for the activation energy of reaction A. So, it has to be higher than positive 29 kilojoules per mole, because here it states that how reaction A fastens up or speeds up when an enzyme is present, and after addition of that enzyme to reaction A, the activation energy that is achieved by that reaction, which is reaction A, is of reaction B. So I'll say maybe 40 kilojoules per mole, and that too positive. You need to mention positive sign. Part 2, the enthalpy change for reaction A is negative 14 kilojoules per mole. Predict a value for the enthalpy change for reaction B. So it will remain as it is, which is 14 kilojoules per mole, because enzymes will speed up a reaction by lowering only activation energy. This has nothing to do with enthalpy of that reaction. Hence, enthalpy of this reaction, of reaction B, is also negative 14 kilojoules per mole. Part 3, sketch a energy level diagram for reaction B. Use relevant values from C part 1 and C part 2. So enthalpy of reaction B is negative 14 kilojoules per mole. It means that it's an exothermic reaction. In exothermic reactions, products have a much lower energy than that of reactants. So reactants over here, and then there will be a hump, and then this is for products. Our reactants were C12H22O11, this reacting with water. In our product is C6H12O6. Okay, so enthalpy of reaction B is almost a half of activation energy of the reaction. Thus, you will see a much bigger hump than the difference in the energy values of reactants and products. So this hump represents activation energy, which is positive 29 kilojoules per mole. And this change in energy from reactants to products, this is the enthalpy of this reaction, which is minus 14 kilojoules per mole, almost half of plus 29. That's why you will see a much bigger hump than this change. But the 1 gram of sucrose is completely combusted. The heat energy produced is used to increase the temperature of 250 grams of water inside a calorimeter from 25 degrees Celsius to 40.7 degrees Celsius. These data can be used to calculate the enthalpy change of combustion of sucrose. Part 1, explain what is meant by the term enthalpy change of combustion of sucrose. So this is enthalpy change when 1 mole of sucrose completely combusts or reacts with oxygen. Part 2, use the data booklet to calculate the enthalpy change in kilojoules per mole for the combustion of sucrose. Assume that all of the heat energy produced is transferred to the water. Show your working. So the chemical equation for this reaction is C12H22O11 plus oxygen. It's best to write the chemical equation before. This gives carbon dioxide plus water. The mass of sucrose being used is 1 grams. And the MR of sucrose is 342. So we can calculate the number of moles of sucrose being used in this reaction, which are 2.924 into 10 to the power of -3. These are the number of moles of sucrose being completely combusted. This moles of sucrose produced how much energy? That energy is what we have to calculate next. So energy is equals to mass multiplied by the specific heat capacity of water multiplied by change which is change in temperature in Celsius. So our energy is 250 grams of water was being used, so 250 multiplied by the specific heat capacity of water, which is 4.8. This can be taken from your data booklet. The change in temperature is from 25 degrees Celsius to 40.7. So this means that the energy released in this combustion reaction is 1640. Next thing we have to calculate is the enthalpy change for the combustion of sucrose. Since you have already mentioned in the question that enthalpy change of combustion of sucrose is the energy required to completely combust 1 mole of sucrose. This much energy was due to combust this number of moles of sucrose. So for 1 number of mole of sucrose to completely combust in oxygen, we will need 5.61 into 10 to the power of 6 joules per mole. Your final answer needs to be in kilojoules per mole, so you need to divide your answer by 1000 to get negative 5610 kilojoules per mole. Negative in sense because enthalpy change for combustion is always negative. Question number 4, part A. An unlabeled bottle contains a straight-chain halogenoalkane Q. The molecular formula of Q is C5H11X, where X is a halogen, bromine, chlorine, or iodine. A test is carried out to identify the halogen present in Q. A sample of Q is added to NaOH and warmed. Dilute nitric acid is then added, followed by a few drops of aqueous silver nitrate. A cream precipitate is observed. Part 1 suggests the identity of X. So test reagents for halide ions are silver nitrate solution or ammonia, whether in concentrated or dilute form. When it says that cream precipitate forms an addition of silver nitrate, this tells us that bromide ions are present. So X is basically nothing but bromine. Part 2, write an ionic equation to describe the formation of cream precipitate, includes state symbols. So halide ion will liberate with silver ion, so it's Br minus plus silver ion. This forms AgBr solid. Silver nitrate was in aqueous form, and so was Q in aqueous form. Part 3, describe a further test which would confirm the identity of X. So you can use dilute ammonia or concentrated ammonia. With concentrated ammonia, the positive result of bromide ion is that your precipitate dissolves. Part B, the reaction of Q with NaOH tends to proceed via an SN2 mechanism. Part 1 suggests the structural formula of the straight chain halogenoalkane Q. So SN2 mechanism means that it has got primary halogenoalkane, or it has got a primary carbocation. So C5H11Br. There's bromide ion bonded to the 5th carbon atom. Part 2, explain why the reaction tends to proceed via an SN2 mechanism rather than SN1 mechanism. So SN2 mechanisms are reactions which involve primary carbocations that are not stable enough to form intermediate products. Here question has bromide ion attached to the carbon atom, which is attached to 2 hydrogen atoms and only 1 alkyl group. So this makes it have less stability or less stable primary carbocation due to positive inductive effect of only 1 alkyl group. This won't proceed with SN1 mechanism because SN1 mechanisms have got intermediates which are very much stable. They have got tertiary carbocations, while SN2 mechanisms have got primary carbocations which are not stable enough to form intermediates, and they directly form products from the reactants. So I'll write that SN2 mechanisms, they form SN2 mechanisms form less stable primary carbocations This stability is due to positive inductive effect of only one alkyl group. The more the number of alkyl groups present near the bromide, chloride, or iodide ion, the more stable the intermediate will be. And there are more chances that then the reaction will proceed with SN1 mechanism. Part C, two different halogenoalkanes P and R, both with the molecular formula of C4H9Cl, are separately dissolved in ethanol and heated under reflux with sodium hydroxide. The major organic product of each of these reactions is methylpropene. Part 1, name the type of reaction occurring. So this is elimination reaction. So type of reactions are like elimination, hydrolysis, hydration, hydrogenation, but type of mechanisms are like addition reaction, substitution reaction, whether nucleophilic or electrophilic. Part 2, write an equation using molecular formula to represent the reaction occurring. So C4H9Cl is reacting with NaOH. This forms methylpropene, which is C4H8 plus NaCl plus water. C4H9Cl won't react with ethanol because it says that it dissolves completely right here, are separately dissolved in ethanol. Part 3, draw the skeletal formula of methylpropene. So methylpropene would look like this. Okay, so this will have a skeletal formula like this. Part 4, give the names of P and R. So this is 1-chloro, 2-methyl propane. Double bonds location basically tells us the position of chloride, and rest of it will remain as it is. Question number 5, the reaction sequence shows how ethene can be converted into other organic molecules. So reaction 1, before we proceed with the rest of the part of the question, I would like to label all the reactions myself. So reaction 1 is hydration, since this is the addition of water molecule to alkene. Reaction 2 is turning primary alcohol to aldehyde group. This is partial oxidation of primary alcohol. Reaction 3 is turning aldehyde to alcohol and a nitrile group. This is nucleophilic addition reaction. Reaction 4 is alcohol and then nitrile. This is reacting with dilute acid. Heating with dilute acid, this means that acid plus water is involved. This is hydrolysis. Reaction 5 is turning primary alcohol to halogenoalkane. This is a substitution reaction, and reaction 6 is turning halogenoalkane to amine, and this is also substitution reaction. Okay, so the next question is asking us, complete the table to give the name of the reaction mechanisms of reaction 1 and 6, the reagents and conditions required for reaction 1, 2, and 6. So name of mechanism of reaction A, reaction 1 is ethene to alcohol. The type of reaction is basically hydration, but they're asking us to name the mechanism in this reaction, which is electrophilic addition reaction. Name of reagents and conditions is, we won't be using just water but steam, plus a catalyst will be used, which is concentrated phosphoric acid. There are more conditions to this reaction, which are that the pressure needs to be around 6 megapascals and the temperature should be around 330 degrees Celsius, but you just need not mention so many of them. So reaction 2 is turning primary alcohol to aldehyde group. This is again partial oxidation. Whether it's partial or complete, we need an oxidizing reagent, which is KMNO4 or K2Cr2O7. So we can write that for this we require hot dilute acidified KMNO4. With this, okay, but for half oxidation of primary alcohol, getting an aldehyde as a product but not carboxylic acid, we need to distill the process but not reflux with the process, because reflux is for getting primary alcohol oxidized to carboxylic acid. But since in this reaction too we are not getting a carboxylic acid right from primary alcohol, we are halfway to getting carboxylic acid. This is an aldehyde, so for aldehyde we need not mention reflux but distill. Okay, so reaction 6 is halogenoalkane to amine. For this, the name of mechanism is nucleophilic substitution reaction. The name of reagents and conditions is alcoholic ammonia plus heat under pressure. Your ammonia needs to be dissolved in alcohol before you mix it with halogenoalkane. Part B. In reaction 3, the organic molecule reacts with HCN and KCN catalyst. Part 1. Complete the diagram to show the mechanism of the reaction occurring. Include all relevant dipoles, lone pairs, and curly arrows in your answer. So the first step is the breaking of C2O double bond. This bond breaks heterolytically, which means that now oxygen will be having a partial negative charge, and this carbon atom will be having a partial positive charge. And you also need to show a curly arrow with its head towards oxygen. Okay, now C being partial positively charged, this will be attracting negatively charged nitrile group, which is this one. So I need to show it with an arrow. Arrowhead will be towards carbon atom. Second step is now this oxygen atom, this oxygen here has got a lone pair, so you need to show the lone pair of electrons. This will be attracting partial positively charged H, which is this one. But right before we do that, we need to label HCN with partial positive and negative charges. Again, this H2CN bond will break heterolytically with H taking a partial positive charge and CN taking partial negative charge, and arrow with its head towards C. Now this oxygen will be attracting the partial positively charged hydrogen, so I need to show that with an arrow. So this oxygen reacting this hydrogen, and the next product is right in front of you. And this time over here, nitrile group with negatively charged being the same because KCN is being used as a catalyst, and catalysts are supposed to remain unchanged during chemical reaction. Part 2, name the functional groups present in the product of reaction 3. So this has got nitrile group, in secondary alcohol, but alcohol will work too. Part C, draw the structure of the organic molecule W formed in reaction 4. So reaction 4 was, so nitrile group and alcohol group is present. So hydroxyl group doesn't change with water plus acid, but nitrile group, which is C2N triple bond, will change due to water plus acid being used, and this will now turn to carboxylic acid group. Hence, W will now have a formula which will look like this. C2N triple bond will now change to carboxylic acid. So I'll go down and redraw the structure. Okay, so this concludes my today's paper. Thank you for watching.